welcome to our mathematics lesson. I am Skulile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. Thank you very much, Christians, for joining us. Remember, we always meet on Thursdays at 9 a.m. Right, today we're going to look at the sine and cosine graphs. Are you familiar with these graphs? Sine and cosine graphs. We're going to learn how to sketch these graphs using the table of values, and also we're going to discuss the key features of these two graphs. Okay, right, that's what we're going to do today. We are going to need rulers. Please make sure you have a ruler. You're going to need a pencil. You're going to need a calculator. Okay, you're going to need a calculator. You're going to need those, even an eraser, so that if you make a mistake you can erase and draw nice diagrams. Okay, right, so let's start our lesson, Cretans. I hope you are ready. Right, today we're going to do point by point plotting of the basic graphs defined by y is equal to sine x, that is the sine graph, and then y is equal to cos x, that is the cosine graph. For which domain? For the x values that are from 0 to 360 degrees, that is the domain, from 0 to 360 degrees. So in grade 10, remember, that's our domain. For all the graphs, we do from 0 to 360 degrees. Okay, right, so that's what we're going to learn today. As we usually do, grade 10s, we start with our baseline activity, but let's just discuss pre-knowledge. We've done trigonometric ratios and trigonometric equations. We're going to use knowledge about those things in this lesson, and also our knowledge about algebraic fractions. As it is now, we're talking about the domain, range. Remember, we've done those under algebraic fractions. It's still the same thing. The domain, we're looking at the x values. The range, we're looking at the y values. We're going to talk about the turning points, the intercepts, and all those key features. Right, let's do our baseline activity. Right, I want you to evaluate the following. What is sine 0, cos 0, sine 270 degrees, cos 120 degrees, cos 150 degrees. Where you have to round off to 2 decimal places. Like throughout the lesson today, if there is rounding off, make sure that you round off to what? To 2 decimal places. I'll give you 3 minutes to do this. Use your calculator. Welcome back, greetings. I really hope that you managed to get the correct answers. Let's mark our way. I'm going to be showing you how to use your calculator to get the answers, and let's try to follow those steps if you did not get the answers correct. Okay, right. The first one, sine 0 degrees. So what you do, your calculator, press sine, then 0, then you can close brackets, and then equals. That's how you put it. And then what's the answer? Equal to 0. Sine 0 degrees is equal to 0. Please don't forget that. We have to know that sine 0 degrees is equal to 0. Okay? Right. Don't forget that. Then let's go to the next one. Cos 0 degrees. Again, we'll try to follow what we have here in the calculator. We have cos, then 0, close bracket, equals. What do you get? Do you see that cos 0 is not 0? It is 1. Cos 0 degrees is equal to 1. Please mark that. Right, and then sine 200. Now you know how to use the calculator, isn't it? Let's say you did not know, now you know. You can try to do C, D, and E very fast before I show you the answers. Let's try to do C, D, and E if you got them wrong. Right, sine 270, how do we do it? We go to sine 270, close bracket, equals, and then -1. That's the answer. Sine 270 is -1. Okay, cos 120. Let's do cos 120. Where do we go? Cos 120, close bracket. 1/2 can press SD, -0.5. Especially if you are plotting graphs, we are going to use we need to have our answers as what? As decimal fractions. Okay, right. It's easy to plot to see where -0.5 is. So if it's a fraction, you press SD, then you need to convert it to a fraction, a decimal fraction. So that is -0.5. Okay, right. The last one, cos 150. So you go to cos, and then 150, close bracket, equals. What do we get? Press SD. Oh, -0.866. Now, because of this 6, what happened to my pen? It's not writing on the thing. Okay, no, it's fine. Right, because you see there's 86 and then the third 6. Because of the third 6, now this second 6 is going to be not the third 6. The 6 on the third decimal place. That 6 will change the 6 in the second decimal place to a 7. So it becomes -0.87. Okay, we said 2 decimal places. Did you get everything correct? Well done. Now, we are going to use this because when we're plotting our graphs or filling our table values, we need to use the skill that you have done here, that you have used here, okay? So we're going to use this later on. Right, let's move on now. Right, so what are we going to look at? The important terms that we need to understand. I'm going to discuss 2 of them now, which is what? The amplitude and the period. Okay, what is the amplitude? Amplitude is the maximum vertical distance between the maximum point and the horizontal midline. Okay, so between the maximum point and the horizontal midline. This is the horizontal midline here. Okay, the x-axis. Right, so most people tend to just check the maximum point there and think that if the maximum point is 2, then they think that the amplitude is 2. No, that is wrong. Because the graphs, you're going to see that later on, we're going to look at the vertical shift. Because this graph may shift upwards or downwards. Let me show you something. Right. Let's say this graph is shifted upwards like this. Okay, and then now the maximum point, let's say for example maybe it's 1,5, and then someone says the amplitude is 1,5. That would be wrong, because even the midline is shifted. It's not like the midline is always the x-axis. No, it shifts with the graph. So to find the amplitude, I want you to stick to this formula. Use this formula to find the amplitude. It's very safe to use the formula, especially after the graphs have been shifted up. So we say y maximum minus y minimum divided by 2. Right, I want you to try this. Your y maximum is 1 for the original graph, not the one that I just drew now. Your y maximum is positive 1, and then your y minimum is negative 1. Can you find the amplitude of this graph? The maximum is 1, the minimum is negative 1. Can you try to do that in 1 minute? Let's try. Welcome back, Cretans. I really hope you managed to get the amplitude. What is it? Amplitude will be 1 minus negative 1. What is 1 minus negative 1? It's like saying 1 plus 1, which is going to be 2 over 2. And then our amplitude is 1. This is the amplitude. Okay, right. Now, that's the first one. Let's go to the period. Right, I put this because you have to know that I said we are doing the domain from 0 to 360 degrees. But now, just for you to be able to recognize this concept period, I'm going to extend the domain from negative 360 to 360 so that you can see when the graph repeats itself. But because if I use just 0 to 360, you won't see the repetition. Okay? So what is the period? So I just extended the domain for that. So the period of a trigonometric function is how often the graph repeats itself. It repeats itself after how many degrees? That's the period. Right. Now, I have this graph. You see, this is the graph here from negative 360 to 0. The graph is like this. You see, it has gone, complete circle, from negative 360 to 0. And then it repeats itself. Same thing, you see, from 0 to 360. So this graph repeats itself after how many degrees? Every 360 degrees, the graph repeats itself. Do you see that? So it means again here is going to be like this, goes. Then 720. You see? Then it goes again. Every 360 degrees, the graph repeats itself. Then the period of this graph becomes 360 degrees. So the period of a trigonometric function is how often the graph repeats itself. So I want us to understand these two concepts before we move on to the sketching of our graph. You're going to enjoy sketching, okay? Right. Now let's move on to the sine graph. Now we know how to use our calculators. We know how to use our calculators. So I want us to fill in the table values here. We are going to substitute x, where there's x, you put 0, you put 30, you put 60, you put 90, like that, till 360, like we did in the baseline activity. Okay, let's do that for 3 minutes. After 3 minutes, we're going to mark our work. We're going to mark and do our corrections before we go to the sketching. 3 minutes. Right, welcome back, grade 10s. Sine 0 is equal to, what did you get? We did this in the baseline. Sine 0 is 0. Mark that. Okay. Sine 30, I won't write all of them, just I'll end with 30. Sine 30 degrees, this is 0 degrees. What do you get? What did you get? 0, 0,5. Okay. And then sine 60 degrees. After rounding off, should be 0,87. Mark that. If you got it wrong, please correct it, because we're going to use these values to plot our graph. Okay, so the values must be correct. Sine 90, what did you get for sine 90? Sine 90 is 1. Remember, cos 0 was 1, so it means sine 90 and cos 0 are almost the same. They are the same, or not almost, they are the same. Right? Sine 120 degrees, 0,87. Please mark that. Sine 150 degrees, 0,5. Sine 180 degrees, 0, 0. Okay, 0, not 0, something. 180, and then 0, sine 180, 0. Sine 210, negative 0,5, negative 0,5. Then sine 240, negative 0.87. Please correct that. Then sine 270, negative 1. Then sine 300, negative 0.87. Then sine 330, negative 0.5. And sine 360, that is 0. So we have from domain, our domain from 0 to 360 degrees there. Okay, now it's time for us to plot the graph, but we need to draw our Cartesian plane. Just make it big, maybe a quarter of a page. Don't make it small, otherwise your graph is not going to be nice. Maybe a quarter of a page or even half of a page is still fine. Between a quarter of a page to half of a page. A quarter is like dividing your page into 4 equal parts. Okay, right, make it big so that your graph will be neat. Right, let's draw the Cartesian plane. We'll do it step by step. Take your ruler and your pencil. Your ruler and your pencil, please. Don't use freehand. It's going to be clumsy. Ruler and your pencil. Let's draw our vertical axis. I said it should be between quarter of a page, half a page. Okay, that is your vertical axis, the y-axis. Okay, draw the y-axis. All right, and then draw your horizontal axis. The x-axis, even if it goes across the page, is still okay. Across the page, from the margin to the margin. Okay, it's still okay. Use your pencil so that if you make a mistake, you can correct. Right, so we have, let's name the axis, let's name them. We have the x-axis and the y-axis. Don't just draw lines without naming them, that would be meaningless, okay? Right, and then the origin, where the x-axis and the y-axis meet, that's the origin, that's our 0 for both y and x. Right, we're going to divide the upper part into 2 equal parts, the 0.5 and 1. So we have 0.5 there, and we have 1 there. Just do that. The top part, 0.5 and 1. Okay, and then below 0, we're going to have negative 0.5 and negative 1. Let's do that. Let's try to move together so that when I finish here, also you have your Cartesian plane. Then we can start plotting. Right, and then let's have our points across. I think we must have, I think it's about 12 points. So we have, this is 60 degrees. So it means here you can even write 30 degrees. I didn't put the 30 degrees because my things were going to be crowded. Okay, but if you have space, you can write 30 degrees there between 0 and 60 degrees. And then 90 there and 120. So you can write 90 there if you have space, or you can just do it like mine so that you know that halfway between 60 and 120 is 90. And then we have 180, so halfway between, we are counting in 30s anyway, so 120 plus 30 is 150, right? And then 180 plus 30 is 210, 210 plus 30 is 240, so here we have 210. 240 plus 30, that is 270. 270 plus 30, that is 300. It means here 270. 300 plus 30, that is 330. Then 330 plus 30, that is 360. So it means here 330. Okay, right. This is our Cartesian plane. Let me just give you 1 minute, maybe for those who are lagging behind, so that we can finish your Cartesian plane. 1 minute to finish off your Cartesian plane before we plot our points. Right, welcome back, welcome back. Now we should be having our Cartesian plane, all of us. Let's have our Cartesian plane. Now, let's go to our plotting now. Right, we have our table of values, the correct one that we corrected. So we're going to plot our points, right? So 0, 0, 0, that's the first point. Okay, let's plot the first point. Okay, 0, 0. And then 30, 0, 0,5. 30, 0, this is 30, and then 0, 0,5 is here. That is 30, 0, 0,5. And then we have 60, 0, 0,87. 60, 0, 0,87, 0, 0,87, almost 0, 0,9. So it should be somewhere, not at 1, just below 1, somewhere there. Okay? And then 90 and 1, 90 and 1, 90 is here, and then 1 is there. Okay, right. I've showed you how to plot. I want you to continue plotting the rest of the points. I'll give you 3 minutes, and then after 3 minutes, I'll show you everything. 3 minutes. Right, welcome back, grade 10. Let's do the sketching together. So you have to compare your graph with mine, okay? Right. So we have the first point, 0, 0. And then at 30, y is 0, 0,5. At 60 degrees, y is 0, 0,87. At 90 degrees, y is 1. At 120, y is 0, 0,87. 150 degrees, y is 0, 0,5. And then at 180, y is 0. It's another x-intercept there. right? Move to 210 degrees, negative 0.5, 240 degrees, negative 0.87, 270 degrees, negative 1. That's the minimum point because the graph now goes up again. At 300, negative 0.87, 330, negative 0.5, at 360, another x-intercept. Okay, right. So our graph should be like this. So that is our graph for f of x. Okay, right. Let me give you 1 minute to just make your corrections before we move on to the cosine graph. But welcome back. Now let's go to the sine graph. Please have your, we're going to the cosine graph. Have your sine graph with you there. We're going to compare them at the end. Right, so let's look at the cosine graph. We are going to fill in the table in 3 minutes. I'm going to give you 3 minutes. Again, let's use the same thing. Now is cos 0. What is cos 0? What is cos 30 degrees? What is cos 60 degrees? Cos 90 degrees up to cos 360 degrees. Use your calculators to fill in the table. After 3 minutes, we're going to mark our way. Let's try for 3 minutes. Right, welcome back, grade 10th. Let's mark our way. Now, cos 0 degrees. What did you get? Cos 0 degrees is 1. Okay. What is sine 0 degrees, by the way? What was it? Sine 0 degrees was 0. Cos 0 degrees is 1. Okay. Right. And then cos 30 degrees, 0, 0.87. Mark that. Cos 60 degrees, that is 0, 0.5. Cos 60 degrees like cos sine 30, ne? Sine 30 degrees. Okay, cos 60 degrees 0, 0.5, and then cos 90 degrees 0. Cos 120 degrees negative 0, 0.5. Cos 150 degrees negative 0, 0.87. And then cos 180 degrees negative 1. Cos 210 degrees negative 0, 0.87. Cos 240 degrees, that is 0, and then cos 300 degrees 0, 0.5, and then cos 330 degrees 0, 0.87. What is cos 360 degrees? It is 1. But sine 360 degrees was what? Was 0. Do you remember? Okay. Right. Now we have our table of values. This is what we're going to use to sketch our cosine graph. Now, I want us to draw the Cartesian plane. I'm going to give you 3 minutes again for you to draw your Cartesian plane. Just like I guided you in the previous one. Just try, draw another one. You don't need to draw on the same set of axes because we want our graphs to be clear and to be neat. So draw this Cartesian plane. You can start as I put these points. And then after I'm done, I'm going to give you 3 minutes. Okay. All right. This is the Cartesian plane. This is the Cartesian plane up to 360 degrees. Okay. 3 minutes, grade 10s. Let's draw the Cartesian plane. Right, welcome back, students. Let's sketch our graph, the cosine graph. Okay, what let me just want to see something. Okay, no, it's fine. Right, let's sketch our cosine graph. Let's come to this point. Right, now, when cos 0 is equal to 1, cos 0 is equal to 1. So where is this graph starting? At 1 here, when the angle is 0, then cos 0 is 1. What's the difference between the cosine graph and the sine graph? The sine graph started at the origin. Did you see that? The sine graph started at the origin, but the cosine graph starts at 1. Okay? And then 30, cos 30, 0.87. Then 60 goes with 0.5. 90 goes with 0. But cosine, the sine graph at 90, it was at 1. Do you remember that? Please take note of these differences between the cosine graph and the sine graph. And then 120, negative 0.5. 150, negative 0.87. 180, negative 1. 210, negative 0.87. 240, negative 0.5. 270, 0. And then 300, 0.5. 330, we have 0.87. Then 360, we have 1. Okay, right, we have our points. We said we're going to do what? Do point by point plotting for these two graphs. We have done that. Remember WhatsApp line, grade 10s, 063-508-1301. Please, if you have any questions, send us a message there, 063-508-1301. Right, then we can join these points. We have our graph for g of x. I'll give you 1 minute just to correct your graph. 1 minute. Welcome back, grade 10. Now we have our two graphs. Let's discuss the key features for these two graphs. I'll be giving you 1 minute for each question. I'll give you a question, 1 minute, then we discuss like that till 10 a.m. Right, let's just do that. Now, the graph of f of x is equal to sine x is drawn below. You can see that. Remember the graph of sine x, we drew that. Now, what is the maximum value of f of x? What is the minimum value of f of x? Right, let me give you 1 minute for these two, for a and b. What is the maximum value for f of x? What is the minimum value for f of x? 2 minutes. 1 minute, sorry, 1 minute, 1 minute. Welcome back, returns. What is the maximum value? That is the maximum value there. So where y is equal to 1, when y is equal to 1, that is the maximum value for the graph of f of x is equal to sine x. Then the minimum value, that is the minimum value there, when y is equal to -1. Okay, when y is equal to -1. We can even talk about the coordinates of the maximum value. The coordinates of the maximum value there is the 90 degrees 1, and then the minimum value, the coordinates are 270 degrees -1. Okay, all right. Would you like to try the next question? Let's see, what does it say? Right, state the range of f of x. Remember from the algebraic functions, what is the range? And then state the amplitude of f of x. What is the range of f of x? What is the amplitude of f of x? 1 minute. Right, welcome back. Thank you very much. There is a question. We're still waiting for the name of the school. Is it necessary to draw the graph on scale? Yes, it is very, very necessary, especially now when we're doing point by point plotting. Otherwise, if the graph is not drawn to scale and you're doing point by point plotting, we are not going to get this shape that you see here. Okay, so make sure that if the gap, like this gap here, we are counting in 30s like this. So the gap of 30 degrees must be the same throughout. And then the gap of 0.5 here must be the same along the y-axis. But later on, you will see that we're no longer going to be plotting using the table values, but using the key points or the key features. You have to know that the sine graph at 0, it is at 0. At 90, it is at 1. At 180, it is at 0. At 270, it is at -1. And at 360, it is at 0. And you just know the general shape of the graph that we're sketching. You see, when you're sketching, we're going to be using the key points or the key features of the graph, and you must know the shape of the graph. When it comes to functions, you get a mark for the shape of the graph. Okay, thank you very much for that question. Right, the range. F of x is equal to sine x. What is the range? The range are the y values. So now if you check the minimum value, we have agreed, we said that the minimum value is -1, but what is the maximum value? It is 1. So the y values are from -1 to 1. From -1 to 1, those are the y values. The range is the y values. So y is greater than or equal to -1, because these -1 and 1 are included, but less than or equal to 1. You can write it like that, or say y is an element of, use square bracket for included, -1 to 1. That is the range. Okay, right, that's the range. And then the amplitude, we talked about the amplitude. We said it's going to be y maximum minus y minimum divided by 2. Let me just use a for amplitude. So it's going to be y maximum, which is 1, minus -1 divided by 2, which is equal to 1. That is the amplitude. Okay, right. Now, what is this period of the graph of f of x? I'm not going to go anywhere. I'll wait for your answer here for 30 seconds. What is the period of the graph of f of x? What is it? What is the period for f of x? We talked about the period. The graph will repeat itself after 360 degrees. Please take note of this and write your notes. Okay, 360 degrees. So, and then need to start again. So the period here is 360 degrees. Period is 360 degrees. Okay, right. Now, and then what we have, state the coordinates of the x and y intercepts of f of x. You see, that's what I mean by this. We have to know the coordinates of the x-intercepts and the y-intercepts. Now, the graph, the y-intercept for sine graph is 0, 0. Is at 0, 0, the origin. Please take note of that. Even the x-intercept, so the origin there, x-intercept and y-intercept. Now, and then we have another x-intercept there. Remember, at the x-intercept, y is equal to 0. So we have 180, sorry, this is degrees, 180 degrees, 0. That's the x-intercept. And then we have another x-intercept there, 360 degrees, 0. Okay, you see that? Remember our domain, grade 10, is from 0 to 360 degrees. We don't do more than that. We don't do less than that. Okay? Right, those are the x and y intercepts. Right, we don't have enough time, so let me just go through the cosine graph. It's basically the same thing like the sine graph, and then after that I'll give you homework. Okay? The graph of g of x, the maximum value for g of x is 1, just like we had for sine of x, sine x. Then the minimum value is y is equal to -1. Okay? If you're asked to write the coordinates of the maximum value and the minimum value, do so. Okay, write the coordinates. You know how to do the coordinates. State the range of g of x and also the amplitude. The range again is going to be from -1 to +1. -1 included, +1 included. So the way we write the range for the cosine graph is the same way we write the range for the sine graph. Okay, then the amplitude is going to be 1 minus -1, which is 1 plus 1, which becomes 2, divided by 2. 1 minus -1 divided by 2. So it means we have 2 divided by 2, which is 1. So the amplitude for g of x is equal to cos x is 1. Okay, right. I'm just rushing. We're left with 4 minutes, but it's okay. We managed to do what we wanted to do. The main thing that was in our objective. Right. So state the period of g of x. What is the period of g of x? And then g of x is equal to, the period. The graph will repeat itself after 360 degrees. The graph will repeat itself after 360 degrees. Now, I want us to take a short break, and then after our short break, we'll come back. I'll give you homework, and then after homework, we summarize our lesson. Okay? Right, let's take a short break. grade 10, this is your homework. So try it. It's very, very easy. You don't need to do any calculation. I want you to recognize, where is f of x minus g of x equal to 1? You must interpret it from the graph. Try that. It's going to be interesting. Right, I'll give you 2 minutes for you to copy the homework, and then after 2 minutes we just what? We summarize our lesson. Thank you very much, Postularis Comprehensive Secondary School, right, for your question about drawing the graph to scale. Thank you very much. Right, let's have our 2 minutes, then after that we're going to summarize our lesson. Right, welcome back, grade 10s. Let's just summarize our lesson. We say that the amplitude of this graph, y is equal to sine x, is 1. Don't forget that. The maximum value of y is equal to sine x is y is equal to 1. Is it y is equal to 1? And then the minimum value for y is equal to sine x is at y is equal to -1. And then the period of y is equal to sine x is 360 degrees. Okay? And then we talked about the cosine graph. We said that the amplitude is 1. The maximum value of y is equal to cos x is at y is equal to 1. The minimum value of y is equal to cos x is equal to y is equal to -1. And then the period of y is equal to cos x is equal to 360 degrees. If you check here, we talked about the things that are similar for the two graphs. But I want you to check, as also your homework, check for the differences. What are the differences between the cosine graph and the sine graph? Knowing those differences is very, very important. Thank you very much, grade 10s, for joining us. We are going to meet next week on Thursday, the 17th, where we are going to look at the tangent graph. Please don't miss the lesson. You are bringing your calculator, your ruler, your pencil, so that we don't disturb each other during the lesson. Come ready for the lesson so that we enjoy and learn. We're going to meet next week, grade 10s. Goodbye.